Hello everyone. In this video, I will be discussing about the important formulas in geotechnical engineering. In first video, I will discuss the soil mechanics part, and in the second video, I will discuss the foundation engineering part. Let's see the important definitions. What is water content? Water content is nothing but weight of water by weight of solids. Water content with respect to total weight is given by weight of water by total weight of soil. Here, Ws is nothing but weight of solids, Wt is nothing but total weight of soil, Ww is nothing but weight of water, Vv is nothing but volume of voids, Vs is nothing but volume of solids, Vt is nothing but total volume of soil, Va is nothing but volume of air. Here, for the range of water content. The definition of water content is weight of water by weight of solids. When weight of water equals to 0, the water content will be 0. See, weight of water can be greater than weight of solids also. So, the range of water content is anything which is greater than 0. Whereas, in case of W dash, if we observe, we have total weight in denominator. That means, W dash is weight of water by weight of water plus weight of soil. If we see this, numerator is always less than denominator. That means, W dash cannot be greater than 100. So, the upper limit is restricted to 100. Weight of water can't be equals to total weight of soil. If it is equal to total weight of soil, it's nothing but water alone, which is not possible. So, the upper limit can't be 100. So, we are writing less than 100 but not less than or equals to 100. These two are the relations between W and W dash. Next, void ratio is nothing but volume of voids by volume of solids, whereas porosity is volume of voids by total volume of soil. Here, void ratio can be any value greater than 0, similar to water content. But void ratio can't be 0 because remember this, volume of voids can never be 0. Since we are having total volume in denominator, this value can't be greater than 100. So, range of porosity is 0 to 100. Since volume of voids cannot be 0, there is no less than or equals to sign here. The relationship between porosity and void ratio is given by these two formulas. Degree of saturation is nothing but volume of water by volume of voids, whereas air content is nothing but volume of air by volume of voids. We know that voids are filled with water and air. That means denominator volume of voids is nothing but volume of water plus volume of air. That means numerator is always less than denominator, so range cannot be greater than 100. If volume of water equals to 0, that is in dry condition, degree of saturation is 0, whereas in saturated condition, that is total volume of voids is filled with water, then degree of saturation is 100. Similarly, when total volume of voids is filled with air, then air content is 100, whereas volume of air is 0, that is in saturated condition, air content is 0. These are the ranges of degree of saturation and air content. Sum of degree of saturation and air content is 1. When we take total volume of soil instead of volume of solids, then it is called percentage air voids. Here, if we observe the range, this can't be equal to 100 because if it is equal to 100, it is nothing but total volume of air is equals to total volume of soil. That means there is no soil. It is totally filled with air, which is not possible. So, this can't be equal to 100. Now, what is bulk unit weight? Bulk unit weight is nothing but total weight of soil by total volume of soil. If that particular soil is in dry condition, then that particular bulk unit weight is known as dry unit weight. If it is in saturated condition, then it is called saturated unit weight. If it is in submerged condition, then that bulk unit weight is known as. This particular unit weights are expressed in Newton per meter cube or kilonewton per meter cube, whereas density is expressed in kg per meter cube or gram per cc. We know this. Now let's see the relation between all the densities. Here, gamma s is nothing but solid unit weight. We will be considering weight of solid and volume of solids alone. This is greater than all unit weight. Here, gamma sat is nothing but saturated unit weight. That is weight of soil in saturated condition. That means weight of solids plus weight of water by total volume of soil. Next comes the partially saturated condition. That is, voids are filled with both water and air. Next, gamma dry. And next, gamma submerged. Gamma submerged is almost equals to gamma sat by 2. Gamma submerged is given by gamma saturated minus gamma W. These are the important definitions in first chapter. Now let's see what are the relations between these definitions. This is very important part in soil mechanics. In every exam there will be at least one question from these relations. The first one is SC equals to GW. This is also called as Sehwag. SC equals to WG. You can remember it this way also. Here SC is degree of saturation, E is void ratio, W is water content and G is specific gravity. Gamma bulk is given by G plus SE gamma W by 1 plus E. For gamma sat, we will be substituting S equals to 1. Then we will be getting G plus E gamma W by 1 plus E. Gamma submerged is nothing but gamma sat minus gamma W. By substituting this, we will be getting gamma submerged as G minus 1 into gamma W by 1 plus E. Gamma dry is nothing but S equals to 0. Then we will be getting gamma dry as G gamma W by 1 plus E. Gamma dry is also given by this formula, that is gamma bulk by 1 plus W. Here W is water content. Gamma dry can also be calculated when percentage air voids is given. That is gamma dry equals to 1 minus neta A into G gamma W by 1 plus Wg. For finding weight of solids, when total weight of soil is given and water content is given, it is given by Wt by 1 plus W. For finding weight of solids, when total volume of soil is given, we can use this formula. These two formulas are generally used in mixing problems and excavation and transportation problems. Here, in case of mixing and excavation problems, weight of solids and volume of solids will never change, but total volume of soil or total weight of soil may change. That means when we mix two soils or when we transport soil, we have to consider that volume of solids is same before and after. Here if we see, GS is nothing but solid specific gravity, whereas GM is nothing but bulk specific gravity. Specific gravity is nothing but unit weight of that soil by unit weight of water. If this gamma is in saturated condition, this GM is nothing but saturation specific gravity. If it is in dry condition, this is dry specific gravity. But this specific gravity of solids is always constant. In all these formulas, this G is nothing but specific gravity of solids, which won't change with respect to type of soil condition. Here, in some questions, they'll be giving GS and G dry, and they'll be asking us what is the void ratio. We can calculate by using this formula. In some questions, they'll be saying that the water added in order to make the soil saturated is seawater. We know that the unit weight of seawater is different and unit weight of normal water is different. Now the question is, what is this gamma W? This gamma W is unit weight of standard water. So we know that only the voids are filled with seawater. This standard G into gamma W will never change. So here in SE gamma W, we have to substitute gamma W of C. There are only few formulas in index properties chapter. One formula is this one, finding water content in cyclometer method. Here W1 is nothing but weight of empty jar, W2 is nothing but weight of jar plus weight of soil, W3 is nothing but this remaining part is also filled with water. The weight is given by W3. The total jar is filled with water, that is given by W4. Then water content is given by this formula, W2 minus W1 by W3 minus W4 into G minus 1 by G whole minus 1. G is nothing but specific gravity of solids. Let's see how to find the specific gravity of solids by using this method. It is given by W2 minus W1 by W4 minus W3 plus W2 minus W1. I have written in this order so that we can remember it easily, that is 4 minus 3 plus 2 minus 1. Here W2 minus W1 is nothing but dry weight of soil. While finding specific gravity, the second jar is filled with dry soil. That is, we don't have water in that. So W2 is minus W1 is nothing but W dry. Next, in particle size distribution, we will be having coefficient of uniformity and coefficient of curvature. Coefficient of uniformity is given by D60 by D10, whereas coefficient of curvature is given by D30 square by D60 into D10. Here we have to remember that for well graded condition, in case of sand, Cu must be greater than 6, whereas in case of gravel, Cu must be greater than 4. whereas Cc must be in between 1 and 3. If this condition is not satisfied, then soil is known as poorly graded condition. That is, when Cc is less than or equals to 1 and Cc is greater than or equals to 3, then it is known as poorly graded. If Cu is less than 6, then it is known as poorly graded sand. As we are covering only the formula part, these are the formulas in index properties. Now let's see formulas in consistency limit. Here, Ws is nothing but shrinkage limit, Wp is plastic limit, Wl is liquid limit. Remember this graph, this is important one. They'll be asking many questions giving volume at liquid limit, volume at plastic limit, and they'll be asking what is liquid limit, what is plastic limit. Remembering this graph and remembering the logic that this slope is constant, we can solve many questions. Now, let's see the formulas. First, shrinkage limit. You have to, this is the important formula. Like many questions we can be solved by using this formula. Shrinkage limit is given by 1 by R minus 1 by G. R is nothing but shrinkage ratio, which is given by this formula, whereas G is nothing but specific gravity of solid. This shrinkage limit can also be found using this. Here, W1 and V1 are nothing but initial water content and initial volume of soil, whereas Vd is nothing but dry volume of soil. Md is nothing but mass of dry volume. Md is nothing but mass of solid. So, shrinkage limit is given by this formula. Plasticity index is given by WL minus WP. Liquidity index and consistency index. Consistency index is given by water content at liquid limit minus natural water content by water content at liquid limit minus plastic limit. Here, if you remember, in consistency index there will be liquid limit, whereas in liquidity index there won't be any liquid limit in numerator. If you remember this logic, you don't confuse between liquidity index, consistency index. Sum of liquidity index and liquid limit is nothing but 1. The shrinkage index is given by plastic limit minus shrinkage limit. The flow index is given by W1 minus W2 by log of N2 by N1. This is nothing but the slope of flow curve. The flow curve is the curve which is used in calculating the liquid limit. That is, at number of blows equals to 25, we will be finding the liquid limit. This is the theory part. We will be discussing the theory part in other video. The toughness index. It is given by the plasticity index by flow index. These are all the limits and definitions used in fine grade soils. These definitions can't be used in case of coarse grained soils. In case of coarse grained soils, we generally use density index, which is given by E max minus E by E max minus E minimum. E max is nothing but the maximum void ratio, whereas E minimum is nothing but the minimum void ratio. E is nothing but the natural void ratio. Void ratio for which we have to find the density index. It is also given by this formula. In case of uniformly graded soil, the maximum void ratio is 0.91, whereas minimum void ratio is 0.35. Sensitivity of soil is given by this formula. Remember, in numerator we have undisturbed case and in denominator remolded case. Next, what is activity? Activity is nothing but plasticity index by percentage of clay particles in that particular soil. The classification of soils is a theory part. There are only two formulas which are to be remembered in classification of soils, that is group index and what is the formula of A line. Group index is given by this formula. Remember this A, B, C, D also. Here A line is given by IP equals to 0.73 into WL minus 20. WL is nothing but the liquid limit. IP is nothing but plasticity index. Here if you remember the theory part, we will be comparing the plasticity index of the soil with respect to plasticity index by using A line, and if it is above A line, we will be considering it as the clay, and if it is below A line, we will be considering it as silt. In permeability chapter, we will be having formulas V equals to Ki and Q equals to Kia. These two are given by Darcy's law. Here, K is nothing but permeability of soil, I is nothing but hydraulic gradient. Permeability of soil is given by units, centimeter per second or meter per second. I is nothing but head loss per length, which has no unit. The seepage velocity is given by this velocity by porosity. We know that porosity is always less than 1. That means seepage velocity is always greater than velocity from Darcy's law. Now, constant head permeability method and falling head permeability method are the experimental methods used in finding the permeability in case of coarse grained soils and fine grained soils. In case of constant head permeability method, we'll be finding permeability by using concept like discharge is nothing but total volume, the total volume collected by the time. Here discharge is given by K into I into A, which is equals to volume by time. In case of falling head permeability method, K is calculated by using this formula. Here A is nothing but this area, capital A is nothing but this area, L is nothing but the length of soil. Here water level is falling from H1 to H2. If in case of falling head method, if the time taken for falling from H1 to H2 and from H2 to H3 is equal, then H2 square is given by H1 into H3. Permeability is given by this formula. Here this formula is not asked directly. We need not remember this formula, but we have to remember that what is the relationship between permeability and these terms. Okay. Generally they will be asking. It is enough to remember whether they are directly proportional or inversely proportional. This is empirical formula, Allen-Hesen formula. Here permeability is given by C d10 square. As it is empirical formula, we have to remember the units also. In this case, d10 is substituted in centimeters and we will be getting permeability in centimeter per second. This particular equation is known as consolidation equation. In this case, K is given by CV mv gamma w. The other thing to be remembered is intrinsic permeability, which is given by K by gamma by mu. Here, if we observe the permeability equation, K is given by this thing. This K is dependent upon fluid properties and the medium property. So, in order to eliminate the fluid property criteria, we will be using K by gamma by mu. That is, if we consider intrinsic permeability, then the permeability is dependent upon only medium properties, that is properties of soil. This particular permeability is given by K by gamma by mu. The units will be meter square or centimeter square. See this, that is permeability is directly proportional to size of the soil square. It is directly proportional to E cube by 1 plus E, which is almost similar to E square. Permeability is proportional to gamma by mu, that is permeability is proportional to density of fluid and viscosity of fluid. We know that viscosity is inversely proportional to temperature. That means by considering this, we can say that permeability is directly proportional to temperature. That is, when temperature increases, permeability increases. Keep in mind that remaining all the conditions are similar and only the variation of temperature is considered. While comparing only specific property, you have to remember that remaining all other properties should be similar. When there are foreign impurities in the soil, the permeability decreases. That is, presence of foreign impurities decreases the permeability. When there is absorbed water on the soil particle, then the permeability decreases. When there is entrapped air in the soil particles, the permeability decreases. These are some important formulas in permeability. This is the first condition is a condition in which the flow is parallel to bed plane. Okay. The effective permeability is given by arithmetic mean, that is sigma ki zi by sigma zi. In this case, the flow is perpendicular to bed plane. Then permeability is given by the harmonic mean, which is sigma zi by sigma zi by ki. Here we know that arithmetic mean is greater than geometric mean greater than harmonic mean. That means the effective permeability in case of parallel to bed plane is always greater than in case of perpendicular to bed plane. Here, if we observe this, in this condition, the head loss is remaining constant, whereas the total flow is nothing but sum of flows in this and this and this plane. In this condition, the head loss is nothing but sum of head loss in first, second, third condition. The separate head loss are given by the total flow by area, which is constant for all the conditions. The head loss in each case is given by this formula. Here Q is constant in all three soils, A is constant in all three soils, Z1 and K1 are varying. Similarly, we can find head loss in second soil and head loss in third soil. In seepage analysis, how to find the seepage head, I will be saying it in theory part, because my suggestion is remembering those formulas creates a confusion. So, I will be covering it in theory part. The seepage pressure is given by the seepage head into gamma W, that is Iz into gamma W. The seepage force is given by seepage pressure into area. The specific seepage force is given by seepage force by volume, which is given by I gamma W. Remember these two, like in generally they will be asking questions like when there is a downward flow, the effective stress increases or decreases. By remembering this, we know we'll be we can answer such questions. Like when there is a downward flow, the effective stress increases because there is a plus sign, that is the seepage pressure is added. When there is upward flow, the effective stress decreases. IC is nothing but the critical hydraulic gradient, which is given by G minus 1 by 1 plus E, which is nothing but gamma submerged by gamma W. The factor of safety is given by IC by I. This is Laplace equation in case of seepage analysis. When there is variation in permeability in x direction and y direction, the Laplace equation is given by this formula. In general, Kx is always greater than Ky. By using seepage analysis, the flow is given by Q equals to K into H into Nf by Nd. Here K is nothing but permeability, H is nothing but head loss, Nf is nothing but number of flow channels. Remember, channels. When they give flow lines, then Nf is nothing but number of flow lines minus 1. Nd is nothing but number of potential drops. When they give number of equipotential lines, we have to subtract it by 1. Here, when there is variation in Kx and Ky, the flow lines will be something like this. That is, we will be having a rectangular flow channel. In order to transfer this rectangular flow channel into a square flow channel horizontally, x transpose is given by x into root of ky by kx. The easy way of remembering is, if you see this, the dimension is decreasing. When we transpose it, we know that kx is always greater than ky. That means xt is given by x into root of which is less than 1. So, we can remember that y should be in numerator. In case of piping, we will be considering the exit gradient, which is given by delta H by L. Delta H is nothing but the head loss in the final drop or final channel by L. The factor of safety for piping is given by IC by I exit. When there are two mediums with permeability K1 and K2, then ratio of K1 by K2 is given by tan of theta 1 by tan of theta 2. In vertical stress distribution of the soil, we will be finding the vertical stress by using some certain theories. By Bosching's theory, sigma z is given by kb into q by z square. Here kb is given by 3 by 2 pi into this one. Here r is nothing but the radial distance at which we are finding the effective stress, and z is nothing but at what depth we are finding the vertical stress. In Bosching's theory, the power is 5 by 2 and we have r square by z square and 3 by 2 pi. Whereas in Westergaard's theory, we have 2 r square by z square and power will be 3 by 2. Okay. And here we will be having 1 by pi, not 3 by 2 pi. In case of circular loading, the sigma z at a depth z is given by sigma z equals to 1 minus cos cube alpha into q. Q is the total loading on this circular cross section. Alpha is nothing but this angle, that is cos alpha is given by z by square root of r square plus z square. In case of line loading, that is loading is in kilonewton per meter. This type of loading is generally seen in retaining walls. Sigma z is given by 2q by pi z. See, here we are having z. That is, here the units are Newton per meter by meter, that is Newton per meter square. If we observe in other formulas, there is no z in denominator. Here x is nothing but the radial distance and z is nothing but the depth. 1 plus x square by z square and the power is 2. In case of uniformly loaded rectangular case, the pressure at the corner at the depth z is given by some coefficient k into q. This coefficient k can be found by using m and n values. Here m is by using m and n values. There is a big formula to find k. We need not remember this formula. By using we have to just have a brief idea that what is m and what is n. M is nothing but b by z and n is nothing but l by z. By knowing these two, we can find k. If this particular p is inside the rectangle, then we will be dividing it into 4 parts such that we will be having 4 rectangles, and we can use this formula by superimposition method. That is, at this corner of this rectangular section, what is value of sigma z and what is value of sigma z for this rectangular section at this corner, similarly this and for this. By adding all these 4, we will be getting sigma z. Similarly, if that particular point is outside also, we can find sigma z by subtracting due to this one and this one. Here we are adding. In case if the point is outside, we will be subtracting. In case of Newmark's influence chart method, the influence factor is given by 1 by m cross n. Here m is the number of concentric circles, and n is the number of radial lines. After finding influence factor, sigma z is given by influence factor into Na into Q. Na is nothing but number of area units occupied by the particular loading diagram. Now, the other chapter is compaction. Compaction is almost a theory chapter. The only formula in the compaction chapter is the relative compaction, which is given by dye density in field by dye density in lab. Substituting what is dye density, we will be getting compaction factor as 1 plus E minimum by 1 plus E. These 5 are the major definitions in consolidation chapter. The first one is coefficient of compressibility, which is given by delta E by delta sigma dash, that is change in void ratio by change in effective stress. The symbol is AV. The units are meter square per kilonewton. In case of compression, the graph is drawn between delta E and log of sigma dash. This is similar to coefficient of compressibility, but in case of compressibility, the graph is drawn between E and effective stress. Here, instead of effective stress, we are drawing for log of effective stress. The coefficient of compression Cc is given by this formula. The coefficient of recompression is given by this formula. Here, the next one is coefficient of volume compressibility. Coefficient of volume compressibility Mv is given by the change in volume per unit volume. Coefficient of volume compressibility Mv is given by change in volume by initial volume by change in effective stress. Delta V by V is derived as delta E by 1 plus E naught. We know that delta E by delta sigma is AV. So Mv is given by AV by 1 plus E naught. The next coefficient is coefficient of consolidation, which is given by Cv. The formula for Cv is K by Mv gamma W. The units are meter square per second. You have to remember this table. This is over consolidation ratio. It is given by the maximum applied stress in past by present. Remember, in past by present. Now let's see how we calculate degree of consolidation. If we consider pore water pressure, degree of consolidation is calculated by pore water pressure at time t equals to 0 minus pore water pressure at time t by pore water pressure at time t equals to 0. Actually, here we will be getting minus pore water pressure at time t equals to infinity. But at t equals to infinity, as total consolidation is completed, the pore water pressure will be 0. Next, by considering settlement. Here, delta H is settlement at time t and capital delta H is settlement at time infinity. With this, degree of consolidation is given by this formula. Degree of consolidation in terms of void ratio. Here, E0 minus E by E0 minus E100. E0 is the initial void ratio and E is the void ratio at time t, and E100 is a void ratio at after completion of consolidation. Now let's see the formula for time factor. Time factor is given by Cv into T by D square. Cv is coefficient of consolidation, T is time, D is thickness of soil. Here, if it is a single drainage, that is the pore water pressure is, in case of single drainage, H is considered as total height H. That is, the pore water pressure is expelled out in only one direction. The other side is the solid strata and water can't be expelled out in that direction. The two-way drainage condition is nothing but the pore water is expelled in both the directions. In that case, D is taken as H by 2. For same degree of consolidation, TV will be same, and for same soil, CV will be same. The empirical formula for calculating TV is given by pi by 4 into percentage of consolidation whole square. If that percentage is less than 60%, we have to use this formula. If that percentage is greater than 60%, we have to use this formula. Now let's see the formula for elastic settlement. It is given by Q into B into 1 minus mu square by ES into this is some factor. Here Q is nothing but the load applied. B is nothing but the width of the footing. Mu is nothing but coefficient of friction. E is the elastic constant. Now let's see what is the final consolidation settlement. It is given by three formulas. The first formula is delta H equals to H naught into delta sigma by 1 plus E naught. And the second one is delta H equals to H naught MB delta sigma. And the third one is in terms of coefficient of decompression. We maximum use this formula only. Delta H equals to H naught Cc by 1 plus E naught into log of sigma dash, that is initial effective stress plus increase in effective stress by initial effective stress. If they give volume compressibility in question, we will be using this formula. If they give void ratio, we'll be using this formula. If they give coefficient of compression, we'll be using this formula. Now let's see important formulas in shear strength chapter. The first one is, what is the critical angle? The critical angle is nothing but 45 plus 5 by 2. This is with respect to major principal plane. You have to remember this. The second one is, sigma 1 is equals to sigma 3 tan square 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2. C is nothing but cohesion. Phi is nothing but angle of friction. Sigma 3 is nothing but minor principal stress and sigma 1 is nothing but major principal stress. According to Moore's theory, we will be getting shear strength as S equals to C plus sigma n bar tan phi. In case of cohesive soils, we will be having C. In case of cohesionless soils, C equals to 0. Now, let's see what is stress path. Stress path is formed by joining all the points of maximum shear stress. This will be in this form. The slope of stress path is given by this formula, whereas this intercept is given by C cos phi. The x-axis of stress path is sigma 1 plus sigma 3 by 2 and the y-axis is sigma 1 minus sigma 3 by 2. In case of vane shear stress, the shear strength is given by T by pi d square into h by 2 plus d by 6. T is nothing but the torque applied. D is nothing but dia of the vane. H is nothing but height of vane. Two-way shearing is nothing but this particular vane is placed inside the soil. The shearing will be in all the planes. In case of one-way shear, the vane will be placed outside. This part of this particular cross section will not be in contact with the soil. In that case, instead of d by 6, there will be d by 12. Now let's see formulas in earth pressure. The coefficient of earth pressure is given by sigma horizontal by sigma vertical. The coefficient of earth pressure at rest is given by mu by 1 minus mu, which is also equals to 1 minus sin phi. In case of active stress, that is, wall is moving away from the backfill, then Ka is given by 1 minus sin phi by 1 plus sin phi. Whereas in passive case, that is, wall is moving towards the backfill, Kp is given by 1 plus sin phi by 1 minus sin phi. You have to remember this relation. Passive earth pressure is greater than neutral one, that is at rest, which is greater than active earth pressure. Pa in case of cohesive soils is given by this formula, that is Ka sigma b minus 2c root Ka. In case of passive case, it is given by Kp sigma b plus 2c root Ka. In case of active pressure, we will be having the critical depth condition, that is the depth at which Pa is 0. The variation of active pressure looks something like this. Here the active pressure is 0. That this depth is nothing but Zc. That means at depth 2Zc, the total active pressure is summing up to 0. This 2Zc is nothing but the critical depth of unsupported head. The critical depth of unsupported cut. By equating this to 0, we will be getting Zc as 2c by gamma root Ka. That means the critical depth is nothing but 2Zc, which is equals to 4c by gamma root Ka. These are the formulas in earth pressure theory. How to solve or how to find the pressure, we'll be seeing that in theory part. In stability of slopes, the normal stress is given by gamma z cos phi beta. Z is nothing but this depth. B is nothing but slope of the terrain. Whereas tau is given by sigma z cos beta sin beta. That is, on this plane, the normal stress is given by sigma n, whereas shear stress is given by tau. The factor of safety is nothing but the shear strength of the soil by tau. We know that shear strength is nothing but C plus sigma n bar tan phi. Now let's see factor of safety in case of cohesionless soils. See, in case of cohesionless soils, C is 0. Substituting sigma 1 and tau, we will be getting in case of dry moist soils, factor of safety as tan phi by tan beta. In case of submerged soils with no flow condition, that is, this particular slope is submerged and there is no flow, then factor of safety is given by tan phi by tan beta. In case of submerged slope but there is a flow, see, this is submerged till H and there is a flow, then factor of safety is given by this formula. Here sigma average is nothing but average unit weight, that is, this Z minus H has bulk unit weight and this particular soil, this H height is in saturated condition by total height Z. When H equals to Z, that is special case, factor of safety is given by gamma dash by gamma sat, that is gamma submerged by gamma saturated into tan phi by tan beta. We know that gamma submerged is almost equals to 1 by 2 times gamma saturated. So that means when soil is submerged and when soil is submerged and there is a flow, there is factor of safety difference of 1 by 2. These are the most important formulas in case of soil mechanics. In next video, I will be discussing the formulas in foundation engineering. I hope this video is helpful in revising all the formulas quickly. Thanks for watching.